Welcome back to some more architectural drawings around blockchain. I'm here with Cale, and today we are going to talk about how smart contracts and accounts get created, and we'll also spend a little bit of time talking about the different types of designs within the actual blockchain infrastructure. So let's go ahead and get started, Cale. Can you tell me a little bit about how we go about creating smart contracts and accounts in an Ethereum blockchain?
Yeah, I think it'd probably be good to start with the account section because that's one of the first things people are going to run into. They're going to say, how do I actually just start creating accounts so I can interface with this thing? Because like I mentioned earlier, you can easily come into Azure and spin up a blockchain, or you can use, like Derek had mentioned, Docker to spin up a blockchain.
Right.
It's very easy to get the infrastructure running relatively.
Right.
But once you get beyond that, you say, okay, now I actually have to use this thing.
Right.
Like,
Now,
how do I start working?
Yeah,
with
what
it?
happened? So let's start with accounts.
So from an accounts perspective, I want to kind of touch on two different models for that because we mentioned before that Shraddha is kind of unique in this space with the API.
Right.
So I want to kind of compare and contrast that with what we have going on in Geth, which
Okay.
is the public and private client that's very popular in the industry.
Okay, let's dive in.
So if we talk about Shraddha, let's talk about that first. So in Shraddha, essentially what we're doing, I mentioned before, we have a block server that's running that's talking to our Shraddha instance, right?
Mm-hmm.
So let's represent our blockchain, and I'm not going to draw it out here again. We're just going to start calling it BC. So that's our blockchain. In this case, it's Shraddha, so essentially we have an API that we're hitting against here, right? And then we're over here on our client side, we're going to have our DApp, our decentralized application, which is basically going to be talking to a block instance. Now, what's kind of cool about this is the block instance can actually live on the client over here, or it could actually live up, in the server
Up in
side.
the server side, okay.
Right, so we could
Very
actually
cool.
stand that up here. So we can
Is
share
there a
an
pro or a
instance.
con to which pattern you take?
Yeah, so basically, this is going to basically hold your key stores, the stuff that you're working with. And when I say key store, that's where your keys get generated.
Okay.
So in Shraddha, essentially, all you have to do is make a call to whatever your API is. So you're going to have your API, like your root URL, and then you're just going to name the account. So you're going to say, like in my case, it would be maybe KLT is my username.
Okay.
And then I pass some parameters in my HTTP post. So this is just a straight up HTTP post. And it's gonna post into this through block into our API.
Mm-hmm.
What's going to happen behind the scenes is it's actually going to generate a key pair for me, right?
So we're going to get a public pair, a public key and a private key.
Correct. It's going to serialize that, and in our block instance, whether it's here or here, there's actually going to be written to the file system a file, basically with our stuff in it.
Okay.
So it's going to have our public keys, our private keys, all those kind of things. It's going to have a derived key of our private key, so we don't have to worry about that being shared or being lost or whatnot. There's still a password involved.
Okay.
Is what I mean.
Okay.
So when that thing gets generated, one of the parameters you pass in is a password, and that will go ahead and create it. It's also going to give you 1,000 ether, right? So you get started.
Nice of it.
Yeah. So you got a nice little faucet there. I wish we could do that in the public space because we
That'd
could
be
just
great.
make lots of money
Well,
and then
yeah.
we wouldn't have to do this anymore. But this is really cool. So we can basically spin that up. And it's literally one post code that you can do.
And then you get all of that.
And you have your account set up. Literally every time you do it, all you need to do is pass your password in and sign your transactions.
Okay.
Now, when we talk about, and maybe I'll do this with a little loop here. We'll just erase this guy. Okay. Well, we lost our thing, but that's okay.
Contracts go over here. That's all right.
That's okay. We'll redo it from here. This is our accounts again. This time we're talking about what's called Geth.
Okay, so first we were talking about Shraddha, which is a blockchain implementation as well as an SDK and an API. Now we're going more pure open source, Go Ethereum from the Ethereum Foundation.
Correct.
Okay.
So essentially we have a blockchain, and if you remember, we talked earlier, this is JSON RPC, essentially.
Right.
So that's how we talk to a blockchain traditionally, whether it's private or public. So over here, we're going to use Geth as a client. So it's a piece of software. Now, what's unique about Geth, when you start getting used to this, you're like, the entire blockchain of Ethereum
runs in that.
Geth. It's a binary.
Right.
Like, how's that possible?
Right.
Like, it's one binary.
One binary. It's got a lot of stuff going on.
So you can basically pass a bunch of parameters to this to make this thing. And then you can use this on your client side.
To be a miner.
To be a miner, to be just a pure client. You can make calls into your blockchain and say, I want to create an account. I want to unlock an account.
Okay.
I want to talk a little bit about this unlocking because this trips people up all the time. So when we first create accounts, so remember the Genesis block, we have some accounts that get created in there by default.
Right.
These are our minting accounts, the first ones that we get. But we can also then start to come in and create other accounts in there, right?
Okay, right.
So when we create these accounts, the thing is they're called personal accounts when we create them on the client side over here.
Right, because we haven't talked about contract accounts yet.
Yep.
Okay.
So basically, when we create these accounts over here, we're creating that key pair again. We're going to generate a key pair. Again, it's going to ask for a passphrase, all those different things that are going to happen, and we're going to end up with this account over here. But the thing is, it's going to be locked by default, right? So essentially up here, the account contract got created.
It's read-only. You can't use it.
So basically, the account contract that lives up here, right? That thing is now sitting there. It exists. We can query it and see it exists, but we can't use it. So we start signing transactions.
You can read and say how much ether is in it.
Correct.
But I can't execute anything off it. I can't send any money out of it.
That's correct.
Okay.
And so in this case, you're going to have to manage the keys yourself again.
Right.
So you got to manage all this. And in this one, you have to write a bit of code over here, right? So I mentioned Web3. And Web3.js, to be specific, is one of the most popular ones over here to get started with this stuff. So when you get started with these blockchains, the first thing you're going to want to do is figure out what client library you want to use. This one being one of the most popular ones, and you can make calls on that. You can also make calls directly into Geth. So this is where things start to get a little muddy. Basically, you can do some stuff here that also crosses over, and you can do from here.
But from a practical standpoint, a lot of the developer world is hanging out here.
Correct.
They're using this as either their client or their miner. They're not actually making tons of code that calls in here. You're really going to use it over the
Correct.
Web3.
I see a lot of people just using Geth to unlock accounts. So they'll come in as a developer and say, I just want to unlock this account so I can do these transactions and kind of play with this.
Okay.
If you actually look at the public code for something like Mist, which is a very popular client for Ethereum, you can download that. It's a GUI-based application.
It sits right on top of Geth.
It's really cool. Yeah, it's basically a GUI for Geth.
A GUI for Geth. Okay, yeah.
So it sits on top of there, allows you to do all kind of contract work. You can create accounts. So it's going to orchestrate a lot of this so you don't have to write a lot of code here. But the thing is, if you look at what it's doing, it's actually making a call to unlock it just for you to do a transaction, and then it gets locked again.
So contrast that for me between accounts that contain ether that are owned by people or things. Contrast that to a contract account.
So there's very little difference between the two, to be honest. I mean, the contract code the account contract, which is an external contract that we're talking about,
right,
or the actual smart contract that we have up there, they both contain a balance, right? The only difference is that we can do certain operations on it. So they know the type. Basically, when we create that contract up there, Ethereum knows the difference between an account contract versus an actual smart contract.
And this is the subtle difference that we talked about in the first module is contract has code.
Correct.
Okay, so my Solidity contract that I'm going to write is going to go into a contract account. It can contain ether or no?
That's correct. It can contain ether.
It can contain ether. Yeah. The difference is that an account contract cannot. That's just correct. Has ether.
Yeah, and if you think about it, one of the things there is we could actually, without a smart contract, transfer ether between accounts.
Right.
We don't even need a smart contract for that. Think about Bitcoin, right? They didn't need smart contracts,
That's
right?
Just back and forth.
We're simply doing that triple entry that we talked about where we do, escrow the money and that kind of thing. So basically, we would have two accounts and we can do a transfer. So there's a special type of command you can call there called transfer to bring those over.
Okay. So here in this last little bit, let's talk about how the architecture of an Ethereum network works, because I know there are a couple of different kinds of nodes that we need to work with.
Yeah, and if you look, when we do our demos, we kind of talk through the templates that we have that we've kind of formed up there around Geth. So if you look at, it's called the Ethereum Blockchain Consortium, or the Ethereum Consortium Network is the template up there in Azure. If you go up and search for that, you'll see that. Now, it's very easy, like we mentioned here before, to just take Geth, right, and pass some parameters to it and start standing up nodes, right, and building your own little private network, right?
Right.
So maybe this is node 1, this is node 2, this is node 3, right? It's very easy to kind of spin that up. But we think, what we were thinking is it's a bit more non-production, right? This is really good to just get this thing stood up.
It's just some nodes.
Right. But there's not really a lot of rhyme and reason for that. So if we looked at what can we do inside of Azure, we could say, well, some things we want to expose to the public.
Right. So literally facing the internet, it's got a public IP address on a specific port. You touch it, and you have the ability to do stuff inside the blockchain.
Right. And so when we form a consortium, and we use that word, I hope we haven't really defined it, but a consortium being a B2B type transaction, right? So we can form a consortium of n number of businesses that want to collaborate together and share some data through a blockchain and work together with that data.
Okay, so they would have maybe business B is over here, and it has a public interface, and it's talking like that.
Correct. So inside, basically what we would have here is we're going to have a series of nodes. So from a standpoint of this, we would have,
Sorry, there you go.
yeah, we would have basically transaction nodes and mining nodes. Right, so these will just be nodes up here, just like we drew over here.
Mm-hmm. Okay, so briefly tell me the difference between a transaction and a mining node as it relates to our consortium.
So the mining node, again, we talked about the mining operations earlier. These guys are just going to be crunching on that data and actually minting blocks. That's their whole goal in life.
And this is for proof of work.
Correct.
Okay.
So these guys can be totally private, right? So that we never need to extend those out to the internet. Now we have our transaction nodes, and the transaction nodes are the things that are going to absorb transactions as you come through.
So you might put a load balancer in front of that.
So we usually put a load balancer here, and then maybe people from the outside, maybe your DApp.
So your MVC or your ASP.NET app would go in from there, or a mobile app.
Correct. Anything that's going to leverage your stuff, it doesn't need to talk directly to the miners. The miners don't even need to be exposed to the internet. The only thing that needs to be exposed is an endpoint to allow you to communicate with it.
But these are all talking to each other.
That's correct.
Okay. So think about it as front tier, middle tier.
Right.
Very cool.
And these guys can be kind of private. I mentioned I have that little slash in there, but these guys are really sitting on a VNet inside of Azure with a load balancer that we're selectively choosing what to expose to the internet.
Standard Azure load balancer in front, and then you can connect your consortium together on the public space. And something that I found really interesting is that these are communicating over HTTP. It's not TLS, it's not encrypted. The data itself is already encrypted, and therefore you have a fairly high sense of security around that.
Yeah, and another thing to kind of touch on here, when you start spinning these networks up, we haven't talked about it a whole lot so far, but peer-to-peer. So these networks that we're building up here, when we talk about spinning up these nodes, whatever we're spinning up here, these guys all communicate through peer-to-peer protocol.
Okay.
Right? So basically there's a discovery protocol that actually happens there inside these systems. So when you go standing these nodes up,
they're going to find each other.
You have to inject certain values first off to say, hey, where do I go get my bootstrap? Like, where are my boot nodes at? How do I get started? Because these guys all know, maybe these guys already know about the blockchain, right? They all know, they're already synced, everybody's in sync, and we add a new node for some reason.
Right.
When that new node comes up, he has to know where to go to say, hey, I need to pull the blockchain for this.
So we're going to have things like network ID,
correct,
the Genesis file, and then these would be seeds. These guys here are like my pointer files to get to the network that I know I want. If I left those out, it would probably take a really long time to find them.
Yeah, and in the public space, I'll touch on this real quick because there's a lot of research and a lot of work going on in this space. You'd think it's a simple process to do discovery, but it's not. When you think about the public space, this is what these blockchains were built around. You don't want to actually have, like if these nodes are in close proximity to each other, that's cool. So if we spin up a new node and he sees that based on ping time, I got a node right next to me, I can use that guy. That's fine. But he also needs to go get a node from really far away.
Way away, yeah, absolutely.
This way, somebody can't plant a bunch of nodes right next to you and compromise your system.
Right.
Because they might be able to just like hurry up and plant a bunch of stuff right near you, then they could change the way your node works.
Absolutely.
You know?
Very good. All right, so that shows the architecture of both contracts and the network design themselves. And we hope you enjoyed this architectural design session. Talk to you soon.